take it away.
So I see it's very exciting, like everybody loves security. So maybe I skip a few slides and just like come to the most important one. This is security therapy, right? So this is essentially where you always start. People are frustrated with security. They hate security. They may have like bad experience with security, especially in combination with platform engineering or DevOps. You essentially move fast, and then you have security coming in, stop. And that is for a good reason, and I think we should like talk about this for a little bit. Just as a background, I'm Chris, CTO at Mondu. I started DevSec.io as an open source project. I also created InSpec in the past, so I work in this space now for quite some time. And we will, like Mondu is a next generation security risk platform. We don't talk about that much. So let's now come back to stereotypes. So we talked about therapy, and therapy normally comes with, you talk to people and they say, hey, those guys are doing this to me. And this is a very interesting perception. And what I've done is I just try to like combine ChatGPT and ask for stereotypes and then like used pictures of it. So essentially, this is how a software developer looks like. Of course, only male, like there's no female developer. And then important is very introverted and has no strong interpersonal communication skills, right? Very important. So this goes on, like DevOps engineer. It's very interesting if you see this picture, like has to like do so many different things. And that's the perception that you always see. And this is, you see already the stereotypes like building up, but still really nice, right? And then test engineers. I don't know what they're doing, but somehow it's working, right? So that's the perception. And system administrator, like this is the most undervalued potentially. Like you see, this is what really AI thinks about us, right? And this, like we wrote this down somewhere. But highly appreciated. The product manager, like he's like juggling and like, this is crazy. Just seeing those things and then seeing all those different perspectives because they all built together a platform, right? And they all have their different perspective. Now, watch how security looks like. Why are they the mean people? Like, why are they the mean people, right? Like, that's not, like, that feels very strange to me because the people that I work with, they're not mean at all. They try to help the organization to get better. And so let's break down this misconception a little bit of why this is actually happening. And one thing that is really broken in the industry is that essentially, if you build an application, let's say I'm the platform DevOps engineer, I build something, I use Terraform, cool, like fast, goes into AWS, and then I think everything is great. Security comes in, runs all those fancy security tools on my AWS cloud, and says, oh, this doesn't look good. Thousands tickets, comes over here. They're like, oh, what the fuck is going on here? Like, why do I have 1,000 tickets now to fix things? And then they have to work through all those tickets, feels really annoying. And then this goes forward, and then this loop takes ages to just complete. And again, we're talking about basic misconfiguration. Why can't security, and this is important here, why it's not security the human, it's security the tool. And so we need to separate the tooling from the human. And I think when we started thinking about DevOps, it was always about bringing people together so that they understand the different perspectives and understand that they need to work together. But now we're talking about the tooling prevents us to work effectively together. And that is like, that's something that we need to think about. Why is the tooling so bad that we can't work together? And of course, there is a solution to this. But that tension can be illustrated with this, right? Like, so why is a company like this shouldn't be, like this doesn't feel right? Like, let's build on something better. And the tension is real, but we don't need to like start a war. But let's talk about the problems and then like figure out what we can do. So let's deep dive a little bit into security because I'm working in security, so I want to share a little bit like why is that so complicated. The first thing that you normally see is we're not talking about small kids doing hacking anymore. Like we're talking about essentially organizations that work highly professional like a normal corporation. They have sales teams, they have support teams, they have payment channels, of course not with credit cards, like they use like crypto and all that fun stuff, but like they have that all. And our CISO, like he has done many of the ransomware negotiations, and this is exactly how it works. So they're very professional, very reliable. They have working hours, so it's also closed at sometimes. So that's really interesting to know. The other thing that happens is that over the last years, we have an exponential growth in vulnerabilities. Of course, we have more software, but that also in combination with the different tool stack that we use, we are not just having the servers anymore. We have cloud, we have SaaS, like we have serverless, like all those things accumulated. Of course, we run more different things, and that's for a very important thing, but now we have all those things to manage. The other problem that we see is the time between a known vulnerability and a fix being implemented. And we see that here in general, 30 days after a CV is known, we have an exploit available. And this is something that I'm still not sure if this is really, really true, but like this is like a public statement from NCC, and it's 250 days fixing critical vulnerabilities in your application. 30 days, 250 days. You see already a gap, right? And then of course, attackers are not doing things manually anymore. Like they have fully automated tooling. You can find them on GitHub. It's not hidden. You can scan the internet in 5 minutes. I'm not sure if you played with Pentest GPT. Now, even if you don't understand hacking, you can let OpenAI hack for you. And so now, this can be fully automated. The ransomware gangs, they have full playbooks, like you have a sales playbook in your company. So they also have white labeling, so you can essentially it's really crazy. So this is fully automated, and you need to assume even if you put 5 minutes into the internet, people can actually find it. Don't forget about compliance. And so that's the fun part, right? So compliance now comes in. We always thought about compliance as this paper thingy. We don't, yes, needs to be done, but actually, we don't like compliance, we only do security. But nowadays, this doesn't work anymore. You need to prove that you actually do real security. And now you see already the different perspectives, and it's really difficult to bring this all together. And we just take a super simple example of security and an engineering team working together. So here we see this is some infrastructure that probably some of you run, and we just pick one. We run a bucket in the cloud, and of course engineers don't think in buckets in the cloud, they think in Terraform, right? So we have 2 technologies here. Oops. And that already hides, okay, even if security finds something here, they say, oh, this bucket is not secure, but the developer thinks about Terraform, where's my Terraform snippet? How do I fix it in Terraform? Why are you giving me this information for AWS? I need this in Terraform. And that's friction. Of course, it's different technology, but that's friction where we don't talk about the same thing. It results in the same thing when I do the automation, but the security tooling doesn't bring this back to you. So it clashes here already in the understanding. So we need to think about this a little bit different. We need to think about how can we make security in a way that actually, as a developer, I can see things early, but not some requirements that somebody wrote, but the requirements that my security team actually approved before. And that's actually really, really challenging. So I don't like talking about, oh, this doesn't work, everything is bad. So I will show you one approach that we do in our open source tooling to actually solve that problem. And I hope you're up for some live demos, and I hope everything works. So this is it's always risky, but let's try. So what we do here is we do just a simple container scan, super easy from command line, like this. Just doing now a scan of the Debian container. It's running policies, vulnerability scan, and boom. I see already, okay, it's not compliant. Even if I don't understand anything, I see, okay, it's red, maybe not so red, and vulnerabilities are never good. So I should always like fix that, right? So that's giving you an interesting idea. Just to show you underneath what's running there, let's do the following. So we connect now to a non-running container image, and we just say, give me all the users in that container, right? So I can say, give me all the name and the UID. So I have essentially full graph, like you see the policy that I was running, but underneath it's all about GraphQL and giving you full power of all the things available. And that's not restricted to individual resources. You can now say group, GID, and the name. And so now I have also the relationships built into that. Let's also do this with packages. And I want to know, like, open SSH should not be installed there. So I do packages, nice. I say where name is something. Oh, let's say SSH. This is great. So now how do I turn this query into an assertion that I want to do for my policy? And I just say, instead of where, I just say none. Boom. So I essentially now say, this should not be there. And this is, of course, a very simple example, but can get very, very complicated. Just to give you one example, like a Vim, this is how a simple policy looks like. You have a policy here, tags, metadata. This includes one query, and then the query has the query, the MQL query that you see here. So it gives you full power to describe everything from the security requirement and also the technical implementation. Now let's see what you can do with that. And I'm not showing you all this in detail, but we can now essentially from ups. Yep, scan. So what we do here is we scan now an EC2 instance without SSH open with EC2 Instance Connect. I'm not sure if you've heard about this, like the new EC2 Instance Connect allows you to not expose a port publicly, but you can still connect to it. And we implement this as well. So what we do here is we essentially use the same mechanism. So the security tooling also should help you not being less secure. Like, why should you expose a port to the internet when this is actually not required? So this internet is obviously not super on our side, so it takes us a hot second. But essentially what's running here, and we can come back to this in a second, it runs now on a Linux box, a full policy with a lot of checks. And at the end, we will see a lot of checks. This is working the same for Kubernetes. So I can run here something against the Kubernetes manifest. So I run the manifest, and then at the end, I see for everything that runs inside of the manifest, in this case, just one, I see the result. But I can also scan the full Kubernetes cluster with the same policies. So that means I have one policy again. Developers can see it here, and the security team can see it here. So that means you have always the same policy that bridges the gap between those teams. And Kubernetes, you say, it's easy because everything is YAML. So that's not a big deal. But we can also do this for cloud. So let's scan a GCP project with a policy here. And that what it's doing is this now, and we can look into this policy in a second. What it's doing, it's running a full policy against GCP. That's live GCP. You scan things here. And I should have like scanned Terraform before. Let's see. Maybe we do this in parallel. While this runs, oh, it comes. OK, great. So this is essentially doing a live communication. Like there's no database involved. Like everything is from your local machine. Like it's just like any command line. So there's really super, super simple. And I just abort this. Oh, maybe not. Go, go, go. Essentially, we see then the output, and then we do the same thing on Terraform. And well, maybe we look into this, how this looks like. Oh, where do I have it? On localhost, I think it's running here. Perfect, yes. So we look into a policy real quick, and that policy is interestingly for GCP, it's where we, like you think about it, like we scan Terraform, which I show in a second, and we scan like GCP, like how is the same policy implementing both things? And we introduce something that we call, like for each check, we implement something like a variant. So I can see, okay, based on like what I'm running against, I now have different kinds of implementation of the check. So in this case, we have this implemented for the runtime, like we check here, GCP project, BigQuery, datasets should all like have no public access. But if we run this on HCL, like we check all the Terraform resources, and by the way, this is not restricted to any like built-in Terraform. You can query all these things, even like your own stuff, and then check all the arguments as well. So that means you have now one policy that you can share, has this shared knowledge included that teams can use in their whole pipeline. And we have here Terraform HCL, pipeline, which means like we have a plan, then we have a state file, and then we have the runtime. And it's the same policy. So now, no matter if you're a developer just using VS Code, if you're building the pipeline, or if you're checking the runtime, it's always the same policy. And when teams now figure out something is not correct, something is red, they know about which check should they talk about. They know exactly what this means. They can attach all those metadata to this requirement. And this is what I mean. Tooling needs you to support you to bring this for the whole chain. So that brings all the teams together and allows them to collaborate and build something that allows them to be much, much better in the way of how they operate with security. We can maybe talk a little bit about what we're covering. You can cover all the clouds, all Kubernetes, all SaaS. Like that's like all open source. You can just like download this right now and use this right now. Like there's, it's essentially a project, a policy. We talked about it. A policy is a metadata. You can share it as an artifact now, a technical artifact that allows you to store it in GitHub, manage it as normal code. Like this is a really, really easy way to do that. And we think about infrastructure as code, like if you use Terraform or Kubernetes, like this is essentially the same for security as code. And in contrast to other engines, this also fetches all the data automatically. You don't need to like think about how do I get all the data, then write rules about it. It's really just getting this together. And we can see here, this is how it looks like, Terraform resources and buckets. Yes, there will be two different implementations, like you can't unify that in a way, but you can now write this custom and use the same graph access to all the resources in that graph to write your checks. The important thing specifically for security is that you can attach metadata. So that's like title, normally like queries will attach like descriptions, audit, and this really is important, especially for people who don't have the technical knowledge. So that is, we believe that security should not be something where you need a PhD, right? So, and let's assume you're just a new starter and you have the tooling, you can just like see this on your computer and you see a description, like this is an opportunity to learn, an opportunity to understand, an opportunity to discuss with your team members. And that's, from my perspective, very, very important to help teams collaborate. This doesn't stop on the policy requirements. We talked a lot about the technical requirements. And the interesting thing is, if you now think about the regulatory compliance that we talked before, like now, this is now not the developers here fighting with the security team here. This is the security team fighting with the compliance team here, right? And this is where essentially we now also allow is also part of the open source tooling full compliance frameworks. So you can now do the full mapping And this rolls now completely up. So if you do a check here and something fails, this rolls up to the security team and rolls up essentially to the compliance team. And that makes it like super easy for all those teams to collaborate and have the same data set, have the same tooling to see everything. And that allows them to see something. You can try this tomorrow. Like hopefully you give me some feedback. Super open, like try it out. But I think it's definitely one way to test this. Here's also like content available, all freely available. You can do this right now. And I think we can, based on this, we can build a world that is more looking like this, like not this fighting world. Let's build this collaborative world, the world where we all work together to make something more secure. We don't want to expose our applications to the internet, to the hackers, when we can prevent this in a very, very easy way. It's really not rocket science. It's something everybody of you can do. That is, you should not be scared of it, really. If you have any questions, like feel free to reach out. I'm happy to help as well, because we really think this is something that makes us to guys better as humans. Okay, thank you very much. I hope.